Welcome everybody. Hope you are all managing to access this webinar. Thank you for joining today's AWRI webinar. My name is Suzanne McLaughlin and I'll be your webinar host today. In this session today, we'll be looking at the Bureau of Meteorology's temperature and rainfall seasonal outlook for the upcoming summer, as well as summarising key findings from the State of the Climate Report and the National Climate Risk Assessment Report. And this is through the webinar titled Climate Trends and Seasonal Outlooks, Insights into Past and Future Changes. So in the spirit of reconciliation, the AWRI acknowledges the traditional custodians of the country throughout Australia and the connections to the land, sea and community. We pay our respects to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. I would also like to acknowledge Wine Australia for providing funding and support for the webinars via the AWRI's Extension and Communication Project. Before we jump in and make a start, a couple of quick reminders to everyone who is new to AWRI webinars. If you'd like to provide a comment or ask a question, please click the Q&A button on the Zoom toolbar and type in your question and click send to get it through to us. We will be holding a Q&A session at the end of this presentation, but feel free to send in your question at any stage. A reminder that this session is also being recorded and the link will be sent through to you later to view via the AWRI's YouTube channel. So for anybody who's just jumped on, welcome. And today's webinar topic is Climate Trends and Seasonal Outlooks, Insights into Past and Future Changes. And it's with great pleasure that I welcome Dr. Jannatun Nahar from the Bureau of Meteorology. Jannatun is an extended prediction specialist in the Environmental Prediction Services team at the Bureau of Meteorology. And with over 15 years of experience in climate and hydrology, Dr. Nahar is an expert hydro-climatologist specialising in climate projections, renewable energy, climate impact assessment, extreme rainfall analysis, and forecast verification. Apologies. And so with that, if you're ready to start, Jannatun, I'll hand over to you and we look forward to your presentation. Thank you.
Thank you, Suzanne. I will just share my screen and let me know if that's coming.
Wonderful. It looks good.
Thank you. Good morning, everyone. My name is Jannatun Nahar. Suzanne already introduced me, and I'm a climate prediction specialist in the Bureau of Meteorology, and I provide climate forecast and analysis to support climate preparedness and to manage climate-related risk. And it's a pleasure for me to be here today. Although the main focus of today's presentation is seasonal forecast, but I will take this opportunity to put the forecast in context of our current climate. And I will talk about our understanding of Australian climate and climate trends. Then I will try to explain where we are sitting in the big picture in light of National Climate Risk Assessment. Let's start with this. Scientific evidence confirms that our climate has changed, with further changes likely. But what are we actually observing? So this timeline here is showing us over the recent decades, numerous record-breaking climate events, including drought, bushfire, heat wave, storms, and floods. So it is quite clear that our climate is changing. But the question is, do we know everything about the future climate that we need to know? Do we know what will be our future climate extremes and where and when it will occur, how frequent, and most importantly, what will be the consequences? So unfortunately, the answers to these questions are unavailable because our current climate is no more a good guide to our future. But the question is why it is not. To explore the answer to that question, why, we dive into the state of the climate. So the Bureau of Meteorology and CSIRO play an important role in monitoring our observed and future changes of Australian climate, and the outcome is presented in a biannual report called State of the Climate Report. So this report is a synthesis of the science informing our understanding of Australia's climate. So the latest state of the climate report, which is the 8th release that came out last year, identified that Australia's climate has warmed by an average of 1.51 degree since 1910. The report also says Australia will continue to see an increase in the frequency and intensity of extreme events like heat wave, bushfire, heavy rainfall. Now, let's have a look at the main findings of this report. I'll start with global temperature. So globally, air temperature at the Earth's surface has warmed by about 1.2 degree since reliable record began in 1850s. So the bar plot here is showing the temperature anomaly for each year. And we can see that each decade since 1980s has been warmer than the previous one. Then if we look at Australia's temperature, the first plot here on the left is showing the time series of sea surface temperature and air temperature anomalies for Australia. The question is, what is anomaly? Anomaly is the deviation from the long-term mean. So as we see, since 1970s, our temperature anomalies are consistently positive, which means we are continuously observing above average temperatures. Obviously, land is heating up more than the ocean. And on the right side, the bar plot is showing the number of days in each year when temperatures are extreme. By extreme, I mean extreme daily mean temperature are the warmest 1% of days for each month. And that's calculated over the period of 1910 to 2023. In last 3 decades, the extreme temperature days are increasing, and you can see from the some of the spikes which are really high. Then we look at the fire weather condition because that's a big concern for Australia. And there has been an increase in the number of days with dangerous fire weather condition for bushfire across the country. Dangerous fire weather conditions for a given location are indicated by an index called FFDI. So this map on the right here is showing FFDI index for two different periods for the country. One period is 1950 to 1986 and the other one is 1986 to current 2024. And then these values were compared. The values of FFDI has changed significantly in coastal Queensland, inland New South Wales, Victoria, and in Kimberley region. I give you one example how it works. Say in 1985, somewhere in southeast Queensland, which is encircled with the black, if the number of days with dangerous fire weather conditions were 5 in a year, that number has become 30 now. That means the frequency of fire season has increased. So not only the frequency of fire weather condition, but also the length of the season has changed too. Here is an example of FFDI index for South Coastal New South Wales on the left-hand side, the dot plots. The dot shows the timing of the year when FFDI index was first time 25. Say in 1970, this was happening in October. You can see from the blue arrow. And then in 19 and then we look at 2010 when we compare this index, it is happening around in August. That means the fire season is starting much earlier. So that's a big concern. Not only the frequency but the duration of the fire season also increased. After temperature, the biggest impact of climate change is on our rainfall. There has been a shift towards drier condition across the southern part of Australia. The map here shows the cool season rainfall, which is April to October rainfall for last 30 years, and it is very much below average to lowest on record compared to the whole record from 1900. And the plot on the right here is showing the change in cool season rainfall for southwest and southeast. In the southwest, of Australia, since 1970, rainfall has declined by 16% in cool season. And for Southeast, this change is around 9% since 1994. So this is one scenario. But there is a contrast in the rainfall change across northern Australia compared to the south. Northern Australia has been wetter than average over the last 30 years across all seasons, especially in the northwest during the northern wet season, which is October to April. The rest of the time of the year, they don't have much rainfall in that part of the country. And the graph here is showing since 1994, wet season rainfall in northern Australia has been 20% above the long term average. So that clearly shows the change and the increase in rainfall. So this was all about the average annual rainfall. If we look at the short duration rainfall, we will see some contrast. The intensity of short duration extreme rainfall events has increased by around 10% or more in some regions and in recent decades, with the largest change observed typically in the region in the north, where daily rainfall totals are associated with the thunderstorm and that have increased. So the intensity of heavy rainfall event is increasing because the climate is warming. How it works? Warmer air can hold more water vapor than cooler air. Moisture in the atmosphere can increase by 7% per degree of warming if all other things remain equal. So this can cause an increased likelihood of heavy rainfall events even in areas where average rainfall is likely to decrease, such as some regions in southern Australia. Probably the annual rainfall is decreasing, but we still see heavy rainfall event. And there has been a decrease in the number of tropical cyclone observed in the Australian region since 1982. But even with the decreased number, the intensity of the cyclones that are coming is going to be higher. Then we look at the stream flow condition. Stream flow is very much related to rainfall, we know. And more than 28% of hydrologic reference stations around Australia show significant decrease in stream flow since 1970, while only 4% of gauges have shown significant increase. By significance, I mean statistically significant change, either increase or decrease. And by HRS gauges, I mean the gauges in catchment with little disturbance from human activities and where we have at least 30 years of good record. And these gauges are indicator of long-term impacts from climate change on stream flow. And if we look at the map, we can see that the significant decreases in stream flow are concentrated more in the southern Australia, while the increases are almost all in the north, which we can see here. And that's quite similar to the rainfall pattern that we just discussed. Next, we will look into the sea level rise. Global mean sea level has risen by around 22 centimeters since 1900, and half of this rise has occurred since 1970. Satellite observation tells us that the rate of sea level rise to the north and southeast of Australia have been significantly higher than the global average. And rates are higher near southeast compared to the south coast, while other coasts are closer to the global average. So in terms of sea level rise, Australian ocean and sea are actually rising at a higher rate compared to the global average. And then we look at sea surface temperature around Australia. The sea surface temperature of Australia has warmed by over 1 degree since 1900. But 9 out of 10 warmest year on record occurred since 2010. So in last 15 years, we have seen the most warming years. The highest average sea surface temperature on record was in 2022. So the greatest ocean warming in the Australian region has occurred in the Coral Sea, and of Southeast Australia and Tasmania, where more rapid warming trends have occurred over the past 4 decades. Then we look at the cryosphere. So this high sea surface temperature is definitely impacting our cryosphere, which is the part of Earth's surface characterized by frozen water. The ice sheets and ice shelves of Antarctica and Greenland are losing ice due to warmer climates, which is contributing to global sea level rise consequently. So here I want to mention, sorry, for the sake of knowledge, together the ice sheets of Antarctica and Greenland contain about 99% of Earth's freshwater, which is equivalent to over 60 meter of sea level rise. That means like if all these ice are melt, so the sea level will go like up to 60 meter higher. So I'm giving this number so that it is relatable to the sea level rise discussion that I just had before. And there has been an abrupt decrease in the Antarctic sea ice content since 2015 that we can see from the line graph. So that was kind of all. And if we look at the summary, so what I just mentioned, we see we will probably observe continued warming with more extreme hot days and fewer cool days for Australia, a further decrease in cool season rainfall, continued drying in the southwest of Western Australia, especially during winter and spring, likely increase in the average duration of drought, a longer fire season, and then more intense short duration heavy rainfall, fewer tropical cyclone, but with high intensity, and then ongoing sea level rise, and then increased and longer lasting marine heat wave, increase in the risk of disaster from extreme weather, including compounding events. So this was all from State of the Climate report. So now I will just focus briefly on some of the impacts of these changes. And there are different kinds of impacts. I will first look at the immediate impacts. So some of these impacts are definitely immediate, and climate change like leads to flooding and pose risk to transport network and properties. It impacts every step of food chain from production to distribution. Maps here are showing the disrupted transport route during flooding and bushfire. Damaged Fitzroy breeze in the Kimberley region from tropical cyclone, I think 2 years ago. The disrupted major electricity transmission network for Southeast Australia. And the cost of these disruption can be really significant. So these are some immediate impact that we just directly see. The one extreme event is just happening in the Queensland and New South Wales now. We have seen in last couple of days, and many houses are still out of power. So these are immediate impact. But if we look at the long term impact, that's not the immediate impacts are not all. There are other impacts on the natural system that happens more slowly, or is the effect of compounding events, and sometimes that could be more serious. Sea level rise is one of that. Sea levels are projected to rise by a meter by the end of this century along the coast of New South Wales. And with 1 meter sea level rise, around 75,000 properties and many kilometers of roads and other infrastructure may inundate during a major storm event. For most of Australia, coastal flooding that currently occur occasionally will become like a chronic event later in this century. Extreme sea levels that had a probability of occurring once in 100 years are projected to become an annual event by the end of this century. So these are some long-term effect. Then I will show some of the cascading impact. The cascading impact of climate change affects response and recovery effort, changing demography in Australian cities. Power outage may leave many residents without electricity. Just gave an example of that. Health impact include outdoor activities will be increasingly difficult because of heat. Emergency services like professional and volunteer emergency service workforce will be at risk and overwhelmed. ADF increasingly expected to assist in civil defense, and capital supply and evacuation, these will be affected. The last one of is an impact is insurance. The impact on insurance over the last 3 decades, insurance cost in Australia has increased significantly, as we can see from this bar plot. And since Black Summer in 2019-20, there has been around 14 declared insurance catastrophe. This has resulted in over 4.5 billion per year in claims cost over the last 5 years. Climate change is impacting affordability and availability of insurance. Some regions may become increasingly difficult to insure, or as the extreme weather risks grow, and some areas probably will be not possible to insure in future. So that was all from the observed climate. Um, Now I will talk through the forecast, the seasonal forecast. So the important thing is to adopt all these changes. And one way of doing this adaptation is to use forecast as a tool for tactical and operational decision making for short-term planning. Let's look at the outlook for the coming high-risk weather season. But I always like to start with this diagram. This is a forecast versus uncertainty diagram to demonstrate the importance of understanding the strength and limitation of any adaptation strategy, especially long range forecast. Bureau of Meteorology issues forecast from minutes to century scale, and every forecast has a level of uncertainty. And these forecasts are used for various purposes. These diagrams show that the longer is the lead for forecast, bigger is the uncertainty. Means we can only say things with certainty when we can see them in the horizon. Today, I will cover climate scale forecast only, which we call long range or seasonal forecast. So I'll start with the recent condition. What we have seen in last 3 months, August to October rainfall was average to above average for the country. Dry in the southeast and slightly wet in the north and west. Both maximum and minimum temperatures were above average in most of the regions, apart from some cool pockets in the southeast. So these are the rainfall deficiency. Sorry. Yep. So these are the rainfall deficiency maps for last 10, 21, and 31 months. This is a way of our tracking cumulative rainfall over longer period. Serious and severe deficiency means rainfall for that period was in the lowest 10% or 5% of historic record. As we can see, there was significant rainfall deficiency in the south, covering parts of South Australia and most of Victoria. However, in 2025, rainfall deficiencies have improved compared to the long term deficiencies that we can see from 10 months deficiency map. So this is the stream flow condition, and we can see below average stream flow recorded across southern and eastern part of the country, and above average in the north, Tasmania, and some part of southwest of Western Australia. This is a storage condition which is important for our water security, and most of the storages are more than half full, except some exceptions. Total storage condition for the whole country is at the moment 69% of full capacity. Now we will look into the rainfall forecast for next 3 months. Rainfall is likely to be below average for most of Australia in December, except some part in the northern Queensland region. For the rest of the 2 months in summer, January and February, roughly equal chances of above or below average rainfall for most of the regions. And some areas of eastern Australia may see above average rainfall during February. But the point here I must mention is that the model forecast may change as we progress through time. Please keep an eye on the Bureau's website for our latest update of long range forecast. So this is the chances of seeing unusual wet condition for the season, which is low, rather a bit of elevated chance of seeing unusual dry condition in the northwest. Then we look into the temperature forecast, starting with the maximum temperature. Warmer than average days are likely across much of Australia during December to February. Chances of seeing unusual warm condition or unusual warm day temperature is high for Western Australia, Northern Territory, Victoria, and very high for Tasmania. Then we look at minimum temperature. Um, Warmer than average nights are likely for most of the country, apart from December, when some parts are expected to see just near average minimum temperature. Chances of seeing unusual warm night temperature is very high for northern part of the country, Victoria, Tasmania, and parts of New South Wales, almost most of the country. The next one is looking ahead to next 3 months season, which is February to April. There is no strong rainfall signals at the moment, but again, this is far from now, and the model run may change over time. And temperature wise, definitely warmer than average day and night conditions are likely. So this is the bushfire outlook. AFEC publishes their summer bushfire outlook yesterday, which shows heightened risk for fire for regions in Victoria, inland New South Wales, and in some parts of Western Australia. Current rainfall and soil moisture are actually dry, and it's widespread across the country, which in conjunction with dry rainfall outlook, we just have seen that, and higher than normal temperature in summer months. All this together will elevate the fire potential in various parts of the country, especially for regions in western and southern Australia, southern western part. The increased bushfire risk potential can be driven by factors like severe rainfall deficit across parts of Victoria, which we have seen in the rainfall deficiency map, along with high fuel load in central northern New South Wales and regions in Western Australia. Then we look at the soil moisture level for next 3 months. Soil moisture levels are high along the coastal region of eastern and northern Australia and in Tasmania. For rest of the country, it's low. And this is potential evapotranspiration and high potential evapotranspiration forecasted for December to February period. And this is warmer month, summer season, so it is quite expected. But that depends on the availability of the moisture supply. So this is a flood risk outlook. So forecast rainfall and runoff suggest average flood risk for parts of Eastern Australia. But even we see the dry outlook, warm waters adjacent to the Eastern Australia may increase the risk of extreme rainfall events, and some of which we are seeing in Queensland now, and that can escalate the flood risk from the extreme weather events. But these kind of flood risks are not easy to forecast, like from long range forecast point of view, particularly in long lead time. Then we look at the tropical cyclone forecast. On average, there are 10 tropical cyclones in Australian region each season, and of them, 4 usually makes landfall. Since 2000, the average number of TCs for each season has slightly decreased, and which is closer to 9 now. Uh, Coastal impacts can still occur from cyclones that don't make landfall. We have seen one example in the Northern Territory in recently, just this week. And then rising sea level are also increasing the risk of coastal impacts from any storm surge, either from tropical cyclone or east coast low. So this is solar and wind forecast. We can see decreased cloud cover expected over much of Australia, which may increase solar radiation during December to February period. Above average winds are also expected along the eastern seaboard, and this will also increase wind power generation. Summer energy demand is typically higher, so forecasted condition can benefit renewable energy generation. This is sea surface temperature forecast, and we can see warmer than average ocean temperature are forecasted to persist across the Australian region in the coming months. Warm ocean can provide increased moisture and energy, and that can enhance rainfall and increase the severity of storm and rain system, especially along the coast. And at the end, these are the climate influences. So this is IOD, Indian Ocean Dipole, and ENSO condition. A negative Indian Ocean Dipole phase is actually underway, but IOD is likely to return to neutral in summer. And most of our models, including Bureau's model, is showing La Nina development, which may return to neutral condition by early summer too. And this is an overview slide of all hazards for the season, for the next 3 month season, and we update this slide every week. And from this, we can see that the elevated risk for this upcoming season is from fire, high temperature, marine heat wave, rainfall deficiency, severe storm, and thunderstorm asthma. And the rest of the hazards have like near average risk. And that's all from the climate outlook. So now I will talk a bit about the Australia's first national climate risk assessment that has published recently. We will see the main outcomes from this report. Before going to the outcomes, let's look at the climate risks first, what we mean by that. Climate change and climate risk are actually two different things. Climate change poses multiple climate related hazards, and hazards are danger or potential sources of danger. And exposure means the threat when there is no protective measure taken. And then when any vulnerable elements of our system are exposed to hazard, then we can call it risk. And response is the measure taken to mitigate, manage, or reduce the risks. So, National Climate Risk Assessment identifies in the first pass of their report 56 nationally significant risks, and out of that, 11 priority risks were taken for further analysis. And in the second pass of the assessment, these 11 priority risks were assessed for 7 key systems. I will talk about the 7 key systems in the next slide. And National Climate Risk Assessment has considered 3 different time frame: current, medium, and long-term horizon. Medium is next 25 years, and longer term horizon is up to end of the century. And this report tells us about the future climate risk at various plausible future conditions or global warming level scenarios. Particularly, 3 warming level were considered: 1.5 degree, 2 degree, and 3 degree. And they were considered for physical risks only. So, so the most important outcome from this report is climate change is not anymore an over the horizon issue. Rather, every Australian is already impacted by it. A national climate risk assessment has assessed climate related risk for 7 key functional systems, as I just mentioned, and these are the 7 functional systems. And this diagram shows where these systems are sitting now and what is projected for them in 25 years of time, which is midterm, and at 2 degree global warming level. The report has assessed it for different time frame and different global warming scenario. I'm just picking one for an example. And this diagram tells us the 3 most already affected systems are defense and national security, infrastructure and built environment, and our natural environment. The report also identifies over time the impacts of Australian society, and the system underpinning them will only worsen. But as I say that, please note that this is not a forecast. Rather, this is an indication if there is no adaptation measure is taken. So last 2 slide was in terms of functional system. This is in terms of hazard. On this slide, we see if we think about our known climate hazards like heat wave, bushfire, drought, hailstorm, and sea level rise, coastal flood, we can see almost everything is going to be intensified in global warming level of either 1.5, 2, or 3 degree. For example, in current climate, if the heat wave days are 4 during 1 year, it will be doubled in 2 degree scenario, 2 degree warming scenario. So if we look at marine heat wave duration at the end of this slide, mm, those are going to increase a lot more. And then in this slide, it's showing the hazards like sea level rise, frequency of coastal flooding, and these are projected to be intensified even more at higher temperatures. This slide is not any particular information, but I still put it because I felt it is important. This is to demonstrate that impacts are widespread across the country and it is not just concentrated in one area. So from these risk and impact, I'll just explain one or two. Let's start with the extreme heat one because that seems like the most important one of the most important. Increase in extreme heat and heat wave will increase health risks, definitely. Heat related mortality may increase relevant to current and vulnerable and disadvantaged people. Emergency responders are more likely to experience these impacts. So this is an example modeled um, showing that heat related risk at various global warming level scenarios for major urban centers of Australia. If we just take Sydney as an example, the heat wave related health risk can intensify from 200 to as high as 444% at different warming scenario, and similar result for other city centers. Then we look at coastal inundation scenario. Sea level rise, I have discussed that from State of the Climate report. It's very alarming, especially for Australia. And sea level rise and coastal hazards will significantly impact coastal communities and cities at various global warming levels. The sea level rise scenario, more than millions of people will be impacted. Infrastructures, housings, and populations are increasingly at risk, and there will be pressure on local economy and services. It's already there, but it will only intensify. And climate driven migration and investments are increasing coastal vulnerabilities also. Then I think the last one. So national climate risk assessment also assess the hazard proneness for various global warming level, considering flood, bushfire, tropical cyclone, and heat wave, these kind of climate hazards. And the takeaway here is hazards from extreme climate event will only increase, and we may see more compounding impacts. I think I'm repeating this, but unfortunately, from each analysis and each slide, that's the outcome. Some of them will be like concurrent and back to back hazard events will become more common. We have seen examples of that already, like back to back flooding, back to back drought. Events will occur in new location where it was not common. Less time between extreme hazard events means less time for communities to respond, which is likely to result in lower resilience and higher costs. And some of the regions where the hazard proneness index is high includes Northern Territory, Queensland North, and Western Australia northern side. And these areas are more exposed. I think that's all from National Climate Risk Assessment, but this is a very big and comprehensive report. So if you want to look into more detail, you can go to the website, Australian Climate Service website, and you will find all this information and the report copy. And for other bureau things, yeah, definitely have a look at our website and keep an eye for updated forecasts, which we update every week. I think that's all from this slide pack. Beyond this, I want to show one of the things that's probably relevant to the group of people present in this webinar. Bureau of Meteorology has different products and services that is focused different communities and group of customers. One of such product is called My Climate View, that's targeted for agricultural community. I will just show you a bit from this. If you can see my screen, so this is My Climate View. If you go to myclimateview.com.au, you will find this, and here you can select any region. I just for the to show quickly, I just typed Adelaide. So if you just type things, then you can select different areas in Adelaide or whatever. I just select Adelaide here, and because this is wine research thing, I just select wine grape, but you can also select a range of products and crops here. So, and if you try to view the information, it will give you something like this, where you can see the rainfall, growing season and non-growing season rainfall, and all aspects for this crop or product. For this is wine grape. And then heat wave and growing season frost, which is also important for grape production. And then you can also download a copy of these climate information for your specific region and for your specific crop of interest. And you can download this, and if you download, that will look something like this: future climate projection for wine grape production at Adelaide. So it will give you the future projection and historic condition, and a comprehensive number that might be useful for the growers. I think that's all I wanted to present today. Thank you all. I'll stop sharing.
Jannatun, thank you so much. Wow, that was a lot of information packed in there. It certainly will be great for us to be able to, hop back onto the various websites and probably take our time to go back through a lot of that and try and sort of absorb the relevant bits that are appropriate to the regions that we all come from. So thank you so much for highlighting where all of the key information is, and providing an interesting outlook for us. To definitely contemplate what our season will be like for the next few months as we ripen our crops, etc. So thank you. I actually had a question for you, if you don't mind. It was interesting to see the storm activity, I think it was, in the northern part of Australia. That certainly seems to be more active or more frequent over time. And I was just wondering, are we seeing sort of spikes in rainfall between October to April that may actually affect the more southern grape growing regions as a result of that more intense rainfall that's happening in the northern parts of Australia?
That's a good question, and that's, I think, a big question where in the region and about the topic where things are very uncertain. As I mentioned, from the historic context and the projection, that we are seeing a drying trend here in Australia, especially in the south, and a bit wet in the north. But this rainfall is not increasing or decreasing systematically. So it's more extreme. So the rainfall total is coming more from extreme events, especially in the north, where it's like warm climate regions, especially in the northern Australia, Kimberley region, and north of Queensland. So most of the rainfall totals are coming there from storm events, and warmer ocean is playing a big role there, rather than the other climate influences like ENSO, IOD, or the other natural thing that we have been seeing historically. So that makes it slightly difficult to forecast because this kind of climate event or storm event can occur anytime, any place, and it is very difficult to predict those kind of things, especially in the long range forecast. So probably for those kind of forecast, it is good to keep an eye on the weather forecast, because as things develop and we can see in the horizon, in the 7-day forecast, they will appear better compared to the long term. So that's a difficult point to make a plan for longer time horizon, but that's the reality.
Mm. I'm also just interested, sorry, if you don't mind, I'm just waiting for some questions to come through, and I just had a few on my mind. Are you seeing, I suppose, or would you be able to comment on, I guess, any improvements that are being made to or have been found with various models that you guys are using to, make predictions, say, for the medium term or I guess short to medium term timeline? Like, do you think are we getting any greater confidence in, say, the 7-day or 14-day forecasts that we're using now than we may have, say, 10 years ago?
Obviously, the short answer is yes,
Yeah.
because we have a better model. We run it more frequently. This is not like deterministic model, so we don't have like one answer. This is ensemble forecast. We have 99 ensemble for season. We start running the model 3 months ahead, and all these every day there are multiple forecasts generated. So we see if most of the ensembles are talking in the along the same direction. So one good example to explain that is when you see our forecast map is white, so it's not on the green side, which is more rain wet side, or not in the brown dry side. That doesn't mean like you will only get average rainfall. That means these ensembles are not talking along the same line, so model is not sure about it. So for those cases, it's better to keep an eye. So as time passed and we approach the time, then the model has better certainty compared to long range, especially during this time of the year. This is critical sometimes, like when spring comes, especially in autumn. This is the breaking time when the system like ENSO or IOD forms. Once these drivers are formed, it's the climate is slightly better predictable. But when those influences are not in action, it's all weather thing, and it's random chaos, and it's very difficult for the model to pick them longer time ahead.
Thanks, Jannatun. No, that's great. We just had a question come through about what was your reasoning for your three global warming levels of 1.5, 2, and 3 degrees, as opposed to, say, using 1.5, 2.5, and 4?
Okay, this is not actually random, because I think I showed this slide at the beginning of ENCRA. Like it says, we have used similar approach that internationally recommended and aligned with IPCC. So what international community is doing, other countries are doing, and these three global warming scenarios represents like low, medium, and high emission. So that's how these has been selected. So this is, there could be many things in between, but these are like more standard thing.
Yep. Thanks so much. Hopefully that's answered that person's question. If not, they may add a little bit more context there. Um, that FFID data that you put there about yeah, the bushfires, etc., I found quite interesting as well. And just having had a little bit of interaction with sort of state governments planning prescribed burns and things, I was just wondering, are you finding more that I guess governments are utilizing this sort of data to potentially, I guess, um, impart into their prescribed burns work and other sort of prevention tasks that they're carrying out during the year? And do you think we'll see much change on the ground in activities as a result?
I think since the last Black Summer bushfire in 2019-20, things has changed a lot. This has been taken with much seriousness, and this is not only Bureau, because Bushfire Outlook is published by AFEC, and we are like experts in climate indices, and they also have their model where they considered fuel load and lots of other local things, and that's how they publish that. And they communicate with the rural agencies and local government. I think at least in terms of bushfire or fire weather, this has been taken with great seriousness in the policy space.
No, amazing. We, in our industry anyway, we tend to always struggle where we have autumn burns. Well,
Mm,
in sort of slightly later seasons, we have that combination where, state governments need to be doing prescribed burns in autumn, and it seems to correspond to the back end of our grape growing season. So we'll sort of end up having that crossover in many of our seasons. So sometimes we're always praying for earlier seasons to try and
mm.
I guess extend that window that we may have to ripen our crops versus when they want to be doing prescribed burns. But yeah, very much down to what the climates are like every year, or what the weather's like every year, whether that's possible or not. So no, that was really
Yeah.
interesting.
One thing from bureau side, I can say we usually provide advice, but the
Yeah,
decision making is not with us.
yeah,
And our advice is like for overall for Australian community and all these even agricultural communities. But what needs to be done in terms of action, that's more with the local
yeah.
government and state government. Yeah.
No, absolutely understand that. Thank you. Well, I don't think I can see any more questions here. So I just,
I can see
or can you
one.
see one? Yeah, I think that was the one that I broached before. Unless I'm missing something, but um, I'll just,
Yeah, I mean, to answer this question, I can
yeah,
see
there's another
the
one. Yep,
question,
yep,
yeah, in Q&A.
yep.
Um, La Nina or IOD trends, if this rainfall change, I would say maybe no, because El Nino, La Nina, or IOD, positive, negative, these are natural variability. If you look at like short term scale, like just year to year, if you look at like 3 years or 4 years, because in just in recent past, in last 5 to 10 years period, we have seen three back to back La Nina event. So if you look at like very short window, you probably see it like, oh, it's a climate change thing. But if you look at the longer time window, you will see that these La Nina and IOD events, they have a natural cycle to come back. And there are lots of other, and that's what we call it, natural variability. So naturally we will have dry spell, wet spell for 10 years or 5 years, and different thing works at different time scale. But the trend of rainfall change is something beyond that, and that's consistent. The difference between trend and variability is always up and down. Sometimes it's high, sometimes it's low, and if you look at the average, it's probably zero. But the trend is like it's consistent, either it will go up or down. For temperature we see up, and for rainfall we see down. So that's beyond this natural variability. So I would say this is a complete different phenomena.
Thanks so much. No, that makes sense. All right. Well, I think you might have just wowed us with all of your information, and it's going to take people a little while to distill and go back and work out what's, I guess, the most meaningful for their regions. But it's great to know what to look out for when you're at different parts of Australia and seeing, what's important for those different regions, etc., because there's a lot going on. So no, that was wonderful. So Jannatun, thank you so much for taking us through, the outlook for the upcoming season and obviously all of those report findings and, providing us where we can go back and find more detail on those reports. That's great. So for everybody on deck, thank you so much for joining us, and hope you got a lot out of today's session. I'd obviously like to thank you so much for logging in and taking part, and remind you all that the link from today's session will be available for you to view from AWRI's YouTube channel. So Jannatun, once again, thank you so much for your presentation today. And on
Thank you.
behalf of the AWRI, thank you. We look forward to seeing you at the next AWRI webinar. Thanks a lot.